Welcome everybody to this video. The topic for this video is binary exponentiation, or in a simple term, what we are going to see is how to calculate a to the power b. But the only difference is the value of a and b will be very large. The brute force method, if I ask you to calculate 9 to the power 100, we will simply do 9 into 9 into 9 into 9 up to 100 times. So if we look into the code, then we will use a for loop which will run from 1 up to 100, and we will do res equals to res into 9, and at the end we will return res. Now this for loop runs for 100 times. So what basically we are doing is we are performing this multiplication operation 100 times to just calculate 9 to the power 100. So now my question is, can we reduce the number of multiplication operations? Yes, of course, we can do it. Here, as you can see, I have 9 to the power 100. I have divided it into two parts, 9 to the power 50 and 9 to the power 50. Now, even if we use the previous method to calculate this 9 to the power 50, we will require 50 multiplication operations. Now, my question is, after getting this value, do we need to calculate this 9 to the power 50 also? Definitely not. Once we get this 9 to the power 50, this 9 to the power 50, the value will be the same. Hence, to get 9 to the power 100, what I can do is I can multiply this value by itself. That is, what basically I am doing is I am multiplying 9 to the power 50 into 9 to the power 50. That is, I am using one multiplication operation, and in that I am getting my 9 to the power 100. So basically, if I am assuming that I am using 50 operations to get 9 to the power 50, I am utilizing one more operation to multiply 9 to the power 50 by itself to get 9 to the power 100. So in short, I am using 51 multiplication operation. So you can see the number of multiplication operation has reduced drastically. It is almost half of what we were using in our previous method. Now my question is, can we reduce it even further? Of course. This 9 to the power 50 I have divided into two parts, 9 to the power 25 and 9 to the power 25. So if I use brute force method to calculate 9 to the power 25, then I will require 25 multiplication operation and one operation to multiply 9 to the power 25 by itself. So I will require 26 multiplication operation to get 9 to the power 50, and again one multiplication operation to multiply it itself to get 9 to the power 100. So in total I am doing 27 multiplication operations. So as you all can see that the number of multiplication operations is now reduced to 27. Now can we further reduce it? Can we further break 9 to the power 25? Yes, of course, we can. But this time we are not going to break it into two parts, but into three parts. 9 to the power 12, 9 to the power 12, and 9 to the power 1. So 9 to the power 12 into 9 to the power 12 into 9 to the power 1 gives me 9 to the power 25. Now, to calculate this 9 to the power 12, I will be requiring 12 operations. Then I need to multiply it itself again, so 13 operations, and then I need to multiply it with 9. So that comes to 14 operations. So I need 14 operations to calculate 9 to the power 25, and then one more operation, 15 operations to get to 9 to the power 50. and in 16 operations it will be 9 to the power 100. So you are going to see that from 100 multiplication operation we have reduced it to just 60. Yes, we can definitely break this node also down recursively until and unless it reaches to 9 to the power 1. That task is up to you all. Try to find total number of multiplication operations we will be needing if we use this method. Now if I talk about the code, it is a recursive function. The first parameter is a and the second parameter is b. We are going to calculate a to the power b. Let's first come into this portion. I have this result power a and b by 2. As you can see, I have divided b into half and then I am calling this recursive function the same function. So whatever be the result, I am storing it into s. Now, if b is my odd, then I am doing res into a. Else, I am just doing result into result. Now talking about the base condition, since it is a recursive function, the base condition is if my b is equals to 1, then I am simply returning a, because a to the power 1 is a itself. Now we are going to modify this code such that this time we are going to use the modular operation. As I have mentioned that a and b are very long. So generally in your question you will get a problem statement like this. Calculate a to the power b modulo a. So here we are going to see how to calculate a to the power b modulo a. It's just a slight modification from the previous code. Here I'm taking a third argument m. Now in my base condition, instead of returning a, I am returning a modulo m. Now the remaining part of the code, if you see, I am just doing the modulo operation on it, so that this does not, even if it exceeds m, it will be reduced to a value which is less than m. So you can see I have just simply done modular multiplication operation here. Similarly, we can do the modular multiplication operation in this else part also. That will be all from this video. Thank you.